Alright, there are two things left before we start the training. At first, we have to create a checkpoint callback to store checkpoints during training. Let's use a callback which only stores the 10 best models based on the validation accuracy. We can define a variable called checkpoint_callback, which uses our model checkpoint. As mentioned, we want to monitor the validation accuracy. Note how the model checkpoint class plays together with our unique identifiers used in the logging functions. This allows to monitor based on all requirements. Next, we have to define that we only want to store the 10 best checkpoints. We can use save top k for this. Last but not least, we have to tell this function that it should store the checkpoints based on the highest accuracy and not the lowest. We can use the mode argument for this and pass the string max. Alright, we have our checkpoint callback. Now it is time to create the trainer. At first, we can define a variable indicating the number of GPUs we can use. In my case, as I have one GPU, I simply use one. If you have multiple GPUs or none, simply adapt this value to your hardware. Now we define our trainer by using pl.trainer. The trainer class of PyTorch Lightning accepts a huge range of parameters, and I highly suggest to take a look at the corresponding documentation, which is linked in our Jupyter notebook. Now we will simply use the ones needed for this training. At first, we pass the number of GPUs. Then we create our logger object by using the TensorBoard logger class, where we can pass our desired save directory. In my case, I want to store everything in a directory called logs. Additionally, by using the log_every_n steps argument, you can define how often you want to log. As I want to receive my logs every step, I simply use 1. Subsequently, we tell the trainer which callbacks it shall execute. You can either pass a single callback or a list of multiple callbacks. For this training, we only need to pass our predefined checkpoint callback. Last but not least, we set the number of epochs to 35. Alright, now everything is ready to start the training. Note that when executing the trainer cell, PyTorch Lightning directly tells us whether GPUs or TPUs are available and if we use some of them. To start the training, we call trainer.fit, pass the pneumonia model as the first argument, the train loader as the second one, and the validation loader as the third. When you run this cell, the training will start. Note that this might take several hours depending on your hardware. We provide the checkpoints for multiple trainings where each training was executed with a different weighted loss. To use TensorBoard, please navigate according to your OS to the corresponding directory and start TensorBoard. The usage of TensorBoard may vary depending on your installation. Alright, let's start the training. As you can see, PyTorch Lightning directly prints a summary of the model and the corresponding parameters, and additionally creates a progress bar. See you after the training.